Welcome to the second video on solving indeterminate torsion problems. In this video, we'll determine the polar moments of inertia for the two bars considered, bar AC, which is solid, and bar CB, which is hollow. We want to go from the shear strain, the maximum shear strain experienced by this, to the torque, because we want to relate the angle of twist to the moment in the bar about the x-axis. So to do that, we're going to have to switch from looking at shear strain to looking at shear stress. So we can do that. The shear stress, well, that's just going to be equal to the shear strain times our shear modulus. Now, this is not given in the problem statement, and so long as it's constant across this whole bar, it is immaterial. It'll just wash out in our calculations, in much the same way the Young's modulus could remain constant in our previous work with beams that were indeterminate. We could still solve those as long as the Young's modulus was constant. The shear modulus here, very similarly, is immaterial. Now, we are also going to want to use this equation for the shear stress, which will relate to the moment, or the torque, I should say. And that is that the maximum shear stress is going to be equal to the torque we apply times the maximum radius. And then we can just divide that by our polar moment of inertia. So we do need to have the polar moment of inertia for this problem. Now, we do remember, of course, the polar moment of inertia for circular shafts, either hollow or solid, is going to be pi divided by 2. Oh, that pi came out really good. Times our outer radius to the fourth minus the inner radius also to the fourth. And we have two cross sections considered. From A to C, we've got a solid piece, and that's got a diameter of 20 millimeters. And then from C to B, we've got an outer diameter of 20 millimeters and an inner diameter of 14 millimeters. So, for this, we're going to have different polar moments so for the from A to C, it's just going to be pi over 2 times 10 millimeters to the fourth, which is going to be 15,708 millimeters to the fourth. And from B to C, or C to B, I guess it doesn't really matter which we call it, it will be pi over 2 times 10 millimeters to the fourth minus 7 millimeters also to the fourth. Let's make it clear that that's not the units that are to the fourth yet, it's the whole thing. And that's going to give us 11,000 936.5 millimeters to the fourth. So now we need to, there we go. So now we need to consider our equations for obtaining our rotations, our twists at point C for these two things, these two bars that are really one bar.